Corporate finance practice problem within OneNote. Future value of a collectible. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you have access and would like to, we're in the tab on the left-hand side. We're in the practice problems, and then down here in the 929 future value of a collectible tab. Also note that if using OneNote, you might want to take a look at the immersive reader. We will typically have a mirroring presentation down here in the text files. Those will be the transcripts. The transcripts can then be listened to in an audio format. They can also be translated to other languages and both read and listened to in the other languages, therefore being a good complement to many of the presentation videos. So I'm going to then close this back up again. Our information is going to be up top. We're then going to work this problem down below in the blue area. We will do so with a mathematical formula. Then we'll do so with a running balance. Then look at an Excel type of calculation and then the tables. So we've seen a future value calculation before. One of the major differences now is just the context that we're going to be running it in. This being an idea that we're going to be putting money into some collectible, such as a painting or like stamps or like collectible wine or brandy or something like that. And then it's going to go up over time, right? So if we put money into our painting of $35,000, then we can estimate what do we think the future value will be. Difficult thing to calculate here, of course, because we don't know, how much of a painting is going to go up. I would think it being more volatile than other types of investments. But when investing, we still want to try to figure out what we think is going to happen. So we're going to say over 14 years that there's going to be an increase 11%. And using that information, we'll do basically a future value calculation. It's going to be a future value of one calculation because we invested in this case in one item, imagining it to be like one painting or something like that. And then we'll apply our future value calculation, starting off doing so with the future value formula. So that future value formula is going to equal the present value, the $35,000 that we used to purchase the painting, times 1 plus R to the N, R being 11%, N being the time of 14. We're going to break that out into like a table type of format. And so I'm going to take the present value times the 1 plus R to the N in the outer column, the 1 plus R to the N, then calculated in the inner column. There's the $35,000 for the present value. Now we're going to calculate the 1 plus the R to the caret N. So 1 plus R, which is going to be the 11%, that's going to give us 111%. When we put that in the trusty calculator, make sure that you're being careful of the decimal. So 1 plus the 0.11 would be 1.11 or 111%. Then we're going to take that to the number of periods, in this case years, that being 14. To do that in our calculator, we need some kind of, I'm going to change this in Windows to a scientific calculator, which provides us the capacity of calculating this. And so I'm going to do this again. This is going to be the 1.11, and then I'm going to say bring this up to the caret up top and 14, and that's going to give us about that 431,044. So I'm going to say, all right, there's the 431,044. It's in percentage format down here. Move the decimal 2 places over. Be careful on how you're utilizing percentages and decimals as you go back and forth between the two. So now that we have those two items, we can multiply these two out now. The 35,000 times this amount is going to be, I'm going to multiply this out about, this is the 35,000, the 158,865, and so on. So there we have that. Scrolling, so that means that 35,000 future value after 14 years, if we have the 11%, we're saying it's going to be at a value, that painting we're imagining, or the stamps, or like the alcohol that gets better apparently with age, 158,865.43. So then we'll go down here and let's see this in terms of a running balance. How much would it go up per year? So we're going to think about how much it would increase per year. Just think about it as a similar kind of situation as if it was money, increasing it per year. This is something that is useful to do. And I'm going to go back to the normal calculator to do it. Normal calculator, make it a little bit smaller. It's harder to do without a spreadsheet, but if you have a spreadsheet, very useful to do. Book problems often do not concentrate on this, but in practice, very useful to understand the concept as well as get more insights that you might be able to use to make decisions on. So we'll say the 35,000 is going to be the first period, and we'll just do our running balance calculation. 35,000 times 0.11, that's going to be the 3850. If I add that to the original 35,000, we're at the 38,850. Then if we take that 38,850, we multiply it once again times the 0.11 for the second period. Now compounding on it, we now have the 4,274 about. Taking that and adding it to where we stood before that, which is the 38,850, we're at the 43,123. Then we could take that once again and multiply it times the 0.11, and we could see it increasing, the amount of interest increasing as we compound. 4,744, adding that then to the 43,123.5 gives us the 47,867, and so on. And we could do this process all the way down for the 14 years. Tedious to do here with a calculator, not too hard, very easy in fact. With Excel, highly recommend practicing with that. We do have this practice problem and others in Excel that you can practice with. That will get us to this 150,865, and we have down here the 150,865 once again. Then we have the Excel formula. This is just a mirror of the Excel formula. This is a similar kind of process that you might do in a financial calculator or in Excel. This is the quickest way to do it. It's kind of a magical way to do it, right? We're just going to put the formula in there. So the calculation would look something like this. We're going to say the future value, the rate in this area, which was B4, which would be the 11. Make sure you're picking up the correct rate in terms of the rate per period. This in years, therefore no change needs to be made. But if we're in months, for example, you typically have to divide by 12, comma, the number of periods, once again in years, would be the 14, comma, because this is not an annuity, we will not have a payment, therefore we have two commas, or you could put a 0 in between there, and then we will have the present value, which is the 35,000, which will magically provide you with the 150,865.43 once again. Let's do this again, this time using tables, this time using the table time. So we got the 14 and the 11%. We'll just look that up on the tables, making sure that we have the proper table, future value of one table. Here's the 11%, 14 periods, which is going to be the 4.3104. So 4.3104, simply taking then the 35,000 times the 4.3104, providing us with the 150,864, which is about what we got in the last calculations, which was slightly different due to rounding. Last calculation being 150,865.43 versus the 150,864.00, due to this calculation only being rounded out to 4 digits, that being good enough for normal decision making. Obviously, if we're trying to think about the value of our collectible painting, it's going to be some type of estimate, and that will typically be in the realm of error or materiality for us. But remember that a book question could get quite picky in terms of the decimals, even though they probably wouldn't matter so much in practice and decision makings, to try to force you to use either one method or another and test you on whether you have indeed done so.